I am Deva Sena. In this lecture, we are going to discuss about mobile network layer and introduction. This topic is present in the subject wireless networks. Systems like GSM have been designed with mobility in mind. The internet started at a time when no one had thought of mobile computers. Today's internet lacks any mechanisms to support users traveling around the world. Is the common base for thousands of applications and runs over dozens of different networks. This is the reason for supporting mobility at the IP layer. Mobile phone systems, for example, cannot offer this type of mobility for heterogeneous networks. To merge the world of mobile phones with the internet and to support mobility in the small more efficiently, micro mobility protocols have been developed. Need for mobile IP. The IP addresses are designed to work with stationary hosts because part of the address defines the network to which host is attached. A host cannot change its IP address without terminating ongoing sessions and restarting them after it acquires a new address. Mobility. Mobility is the ability of a node to change its point of attachment while maintaining all existing communications using the same IP address. Nomadicity. Nomadicity allows a node to move, but it must terminate all existing communications and then can initiate new connections with a new address. Mobile IP. Mobile IP is a network layer solution for homogeneous and heterogeneous mobility on the global internet, which is scalable, robust, secure, and which allows nodes to maintain all ongoing communications while moving. The representation of 7 layers OSI model is shown below. This OSI model comprises of physical layer, data link layer, network layer, transport layer, session layer, presentation layer, and application layer. The lower 4 layers, that is physical layer, data link layer, network layer, and transport layer, are also called as hardware layers. The upper 3 layers like session layer, presentation layer, and application layer are called as software layers of OSI model in both the sending computers and the receiving computers. And this is the diagram. In the sending computer, the application layer performs application to network interaction. The presentation layer performs compression and data sequence. The session layer manages opening, closing, connection. The transport layer performs port destinations encapsulation. The network layer performs network address encapsulation. The data link layer performs HW address encapsulation and is transferred through the physical layer in the sending computer side. Now we will see the receiving computer side. In the receiving computer side, the data transferred from the sending computer is received in the physical layer of the receiving computer. The data link present in the receiving computer evaluates HW address. Then the network layer evaluates network address evaluation. Transport layer evaluates port destination evaluation. Session layer evaluates manages connection negotiation. The presentation layer evaluates compression and data sequence. The application layer in the receiving computer evaluates application to network interaction. These are the functions performed in sending computer and in receiving computer. The network layer functions. Network layer translates logical network address into physical address concerned with the circuit, message or packet. The primary function of the network layer is to permit different networks to be interconnected. It does this by forwarding packets to network routers, which rely on algorithms to determine the best path for the data to travel. These paths are known as virtual circuits by physical layer, MAC layer and network layer representation. The data transmission function is performed by the physical layer. Spectrum sharing function, spectrum mobility function, spectrum sensing function is being done by the MAC layer. The spectrum sensing function is also being done by the physical layer, and the network layer's functions are host addressing function, IP datagram fragmentation function and the routing function. The spectrum decision function is being done by network layer as well as the MAC layer. This is indicated in this diagram. Layer. In the sending side, from the network layer, data is passed to the data link layer and then it is being passed to the physical layer. In the receiving side, data is passed from the physical layer to the data link layer, and from the data link layer it is being passed to the network layer that is present in the receiving side. The flow diagram is represented here. Layer. The network layer provides services to direct packets to a destination host on another network. To travel to other networks, the packets must be processed by a router. The role of a router is to select paths for and direct packets towards the destination host in a process known as routing. Connection services are provided including network layer flow control, network layer error control and packet sequence control. Same goals for mobile IP. Mobile IP was developed as a means for transparently dealing with problems of mobile users. Mobile IP was designed to make the size and the frequency of required routing updates as small as possible. It was designed to make it simple to implement mobile node, simple to implement mobile software. It was designed to avoid solutions that require mobile nodes to use multiple addresses. For mobile IP, the basic requirements for mobile IP are compatibility, transparency, scalability and efficiency, and security. The whole architecture of internet is very huge and a new standard cannot introduce changes to the applications or network protocols already in use. Mobile IP is to be integrated into the existing operating systems. Also, for routers, it may be possible to enhance its capabilities to support mobility instead of changing the routers, which is highly impossible. Mobile IP must not require special media or MAC LLC protocols, so it must use the same interfaces and mechanisms to access the lower layers as IP does. Mobility remains invisible for many higher layer protocols and applications. Higher layers continues to work even if the mobile computer has changed its point of attraction to the network and even notice a lower bandwidth and some interruption in the service. As many of today's applications have not been designed to use in mobile environments, the effects of mobility will be higher delay and lower bandwidth. And efficiency. The efficiency of the network should not be affected even if a new mechanism is introduced into the internet. Enhancing IP for mobility must not generate many new messages flooding the whole network. Special care is necessary to be taken for considering the lower bandwidth of wireless links. Mobile systems have a wireless link to an attachment point. Therefore, only some additional packets must be necessary between a mobile system and a node in the network. It is indispensable for a mobile IP to be scalable over a large number of participants in the whole internet throughout the world. Security. Mobility possesses many security problems. A minimum requirement is the authentication of all messages related to the management of mobile IP. It must be sure for the IP layer if it forwards a packet to a mobile host that this host really is the receiver of the packet. The IP can only guarantee that IP address of the receiver is correct. There is no way to prevent faked IP addresses and other attacks. Thank you very much for listening this lecture. For further updates, kindly subscribe this channel. If you like this video means you can share this video to your friends.